Good afternoon. Thank you very much for showing up for what promises to be a very engaging afternoon of conversation about the global semiconductor industry. Before we get going, I just wanted to briefly introduce the Technology, Innovation, and Global Security Program of the Robert Strauss Center for International Security and Law, which is sponsoring this event. Over the course of the next 3 months, we're going to have a series of speakers, and we're beginning the speaker series with what I think is going to be an enormously significant event for us, and that is hosting Dr. Morris Chang, the founder of Taiwan Semiconductor Manufacturing Corporation. We have some equally, or if not equally, also almost as interesting guests lined up later in the semester. And of course, you're all going to be invited to that event as well. Without further ado, I'm going to turn the floor over to Dr. Bill Spencer, who is going to introduce Morris Chang. Thank you.
I'll let you take this. We're on, I guess, now. Let me add my... we're really on. Let me add my welcome to this series and to the students who are here from our class, and remind you that you have an assignment due before midnight on Friday this week. Everyone knows what their assignment is, and it's due on the web on our site before Friday. We are very fortunate today to have Morris Chang. If you went around the world and looked for somebody who's a leader in technology and innovation particularly in a global sense, it'd be difficult to find someone who has a more distinguished career than Morris. Morris was born in China and moved to this country in 1949, a very good time to get out of China and come here for a while. He was accepted at Harvard, and after a year there found that MIT met his interests more. And he graduated with his bachelor and master's degree in record time. And that was a harbinger in my mind of what he was going to do the rest of his career. He stayed here and worked with Sylvania for a while and then joined TI. And a very enlightened, in 1958, and a very enlightened manager there recognized Morris's talents and sent him to Stanford for his PhD in electrical engineering. He actually, when we talked last night, it turned out John Mall was his thesis advisor, and John of Ebers and Mall fame had been at Bell Labs. I'd known John briefly. Morris stayed on at TI for 25 years. And then after a brief hop to General Instruments, Taiwan recruited him. And he moved there and in 1987 started a Taiwan Semiconductor Manufacturing Company. And before I extol the virtues of that company, let me say just a couple of words about Morris and the honors that he's gotten since that time. There are too many to go into, and I only want to mention one. In the year 2000, he received the Robert Noyce Award from the IEEE, the big engineering society in this country. And many of you will remember that Bob was the first CEO of Semitech here in between 1988 and 1990. Well, that recognition was because of the huge success that TSMC has enjoyed in the 20 years since it was founded. Today, it's the largest company, not the largest semiconductor company, but the largest company in Taiwan. It has a market cap of about $60 billion. The only other semiconductor company that's larger than that has a lock on the microprocessor market, and that's our friends at Intel. And they're the number 5 semiconductor company in the world today, and by far the largest foundry company in the world, with about 50% of the market share for that. So not only did Morris initiate a new concept in pure play foundries, but that generated a whole new business of fabless semiconductor companies. And that's an extremely large business today, several here in Austin, and companies all over the world. So TSMC has to interface with companies sending them designs from everywhere in the world. Now, you might think after 20 years, the bloom is off and it's slowed down. Not so. In the first half of this year, TSMC grew 30% in an industry which is growing around 5% plus or minus a little bit, 30%. So they're continuing this amazing growth pattern which they've had since 1987, and this year will do in excess of $11 billion in sales. Now, Morris, with all of that amazing growth, for those of us who are not really certain, could you give us an idea of what a foundry is today, and what the business model has been for TSMC and why it's been so successful?
Thank you, Bill. A foundry is a company that makes ICs. We don't design the ICs. We don't market the ICs to the users, but we make the ICs. Our customers are semiconductor companies. Most of them are fabless semiconductor companies, and I think that there are quite a few customers in this gathering: Freescale, AMD, Silicon Lab. I understand that Samsung also has facilities here, but I don't believe Samsung is a customer of ours, at least not yet.
A competitor, maybe, is it?
So the business model was a very new one when we started the company, because the IC industry has had just one business model ever since its inception. The semiconductor industry, I should say, has had just one business model. That's the vertical integration business model. And we started and changed it. We were the first one. We were the only one at that time that built ourselves as the pure play foundry. The significance of a business model, of course, is who your customers are. In our business model, our customers are the semiconductor companies, very different from IDMs. IDM's customers are the computer makers, the telephone makers, the equipment makers, all those. But our customers are were and still are the semiconductor companies. And that's the basic innovation, business model innovation. We started from there. There was a lot of execution, of course. See, this business model bred a completely different corporate culture. With the IBM, the usual IBM, frankly, is a commodities house. Yeah, sure, I think there are differentiations between one company's product and another company's product, but usually those differentiations last only a rather short time. And basically, with the possible exception of Intel, but Intel, even in their other products, their microprocessors, is in the commodity market. Right? So they are in the commodity markets, whereas we, the pure play foundry, are in a truly custom market. And the customer service customer satisfaction is our first priority. I'm not. I mean, everybody says customers are important, but to us, it's a question of survival. So that's why I said that it bred a different corporate culture. The corporate culture is one that seeks customer satisfaction. And we have 4 values in the company. Integrity is very important. Commitment, basically employees' commitment to the company, and vice versa, company's commitment to employee. Innovation, of course, is very important. And then lastly, but not leastly, partnership. Every customer, we try to make him a partner. And in a very true sense, this is true, because the word partner basically means that you're on the same side, and no, the foundry has to be on the same side as its partner, as its customer. So to us, it's very important: customer satisfaction and partnership.
Morris, you pointed out that in '87, when you started this, it was a new model. You've not only generated the foundry model, which today must be close to $25 billion in sales, but also the total fabless market, which didn't exist. There wasn't any place for people who designed integrated circuits to get them made before your model came along. Was there something that was going on in '87, or something that occurred before that, or what made you think it was the time was ripe to start this foundry model?
Well, actually, when I was at Texas Instruments and General Instrument, I noticed that engineers, a lot of engineers were leaving. Some of them left to form their own companies. A lot of them left for other companies, but they really wanted to form their own companies. Now, the thing that stopped them from forming their own IC companies was the heavy capital requirement of a fab. I remember in the middle '80s, it took only about $5 to $10 million to start a design company. If you didn't have to have a fab, it would require only $5 to $10 million to start an IC company. But most people felt that they needed a fab. And if they needed a fab, it would take $50 to $100 million to start an IC company. One order of magnitude difference in capital requirement. Now, there were a few daring souls that didn't have fabs. They started their companies without a fab anyway. So where did they go for their fab? They had to go to the IDMs. And most IDMs, frankly, had done foundry at one time or another. But they did foundry work only as a sideline. In fact, not just as a sideline. They treated their customers as competitors. They were competitors. And most of them, in fact, I think all of them, to my knowledge, wanted the product right. They wanted the right to sell the products under their own brand when they accepted the fabless company's request to manufacture the stuff for. And this, of course, resulted in in all kinds of difficulties. In fact, resulted in lawsuits in a few cases. So I saw that. So I felt that given time, we would develop a market. We would have customers. When we started at TSMC, there were a few fabless companies already, but not many. There were maybe, in fact, I had the numbers. I got the numbers from the Fabless Association, now called the Global Semiconductor Association, GSA. They kept the statistics all the way back to the middle 80s. And the fabless company sales were very small at that time. Now, once we started, people began to realize, the would-be entrepreneurs began to realize that now there was this company, Pure Foundry, that would be very happy to accept their fab orders. Of course, we were still behind in technology in the late 80s. But once we began to catch up on technology, and it took us more than 10 years, but we gradually caught up. We were, at first, when we started, we were 2 generations behind, 2 nodes behind. And then within 4 or 5 years, we became only 1 generation behind. And being 1 generation behind was already, already allowed us to take a lot of orders because many people don't really require the leading edge technology. And then in 10 years, we almost completely caught up. We didn't catch up completely with Intel, but we certainly caught up with many other companies in the field in the late 90s. So by then, our customer base just exploded, and by then also, the fabless industry started to blossom in the early 90s. Once they found out that there was a reliable supplier, reliable foundry, fabless industry began to explode. So now it's 25, as you pointed out, about $25 billion, maybe a little less, because all you have to do is usually is just to multiply our sales by 2. You get the total foundry industry number. So let's say we're going to do maybe $11 billion. So let's say it's $22, $23 billion for the industry. But the impact is more than the 22, 23. You normally have to multiply that number, the foundry sales number, by about 3, 2.5 to 3, to arrive at the final IC sales number. That means that 22 billion multiplied by, let's say, by 3, 60-some billion. 60-some billion is the sales of the ICs that we make, the foundry industry makes. And that's more than 20% of the total IC industry.
Right.
Yeah.
For those of us who don't remember, a generation in silicon technology used to be about 3 years, and then since 1995 or so, it's speeded up to every 2 years. And some of the people who looked at that said, well, it's speeding up just before it hits a wall, and somewhere we're going to hit that wall. That was a truly amazing thing, and to generate these 2, not just 1, but 2 new industries. You think today that picture's changed? Are there still a lot of opportunities for fabless semiconductors to start? And what about foundries? Now that you've shown the way, are there going to be a lot of new foundries?
There are altogether 15 to 20 foundries in the world now. And most of them are small. There are only a few big ones. We are the biggest, of course, but the next largest is only about a quarter of our size. And number 3 and number 4 are about half of number 2's size.
Is UMC another company in Taiwan that's in the foundry business? Or
UMC is the second largest.
Second.
Yes. They're about a quarter. In sales, they're about a quarter. In profit, well, our profit is more than the aggregate profit. So we're making all the profit. We're making more than all the profit in the industry. Mm-hmm. It's yeah.
So you're the Intel of the foundry business.
I don't want to compare ourselves to Intel. Now you talk about fabless. Yeah, I think there are plenty of opportunities for fabless. For foundry, as I said, a lot of people emulated us since we started, but not really. I can't think of any that's really successful in terms of making a profit anyway. I think each of them did sort of get a share of the market. That's why we have only 50% instead of 100%. You know. So, but I can't think of anyone that's really successful. Now, in the last 5 years, a lot of small foundries have sprung up in China, and they all use old technology, 0.18 micron or older, 8-inch wafers. Of course, China has one quite modern foundry, that's SMIC, and SMIC has 12-inch wafers, and they also have more advanced technology.
But no profits yet.
No, they've been losing money, I think, every year. Yeah. So for the fabless companies, I think that the future is still unlimited. As you pointed out, Moore's Law certainly hasn't hit the wall yet. I remember a dialogue I had with Craig Barrett. The two of us were sitting in Taipei in front of a small audience just like this one, just as you and I are sitting here now. And this is 2008. Well, that was 1998. I think around 1998 when Craig Barrett and I were talking in front of an audience. And I predicted that Moore's Law had 10 to 15 years to run. And then he said, well, maybe I would say 10 years. He was more conservative than I. Well, this was 1998. And I noticed just 2 years ago, 2006, I noticed in the paper that Craig Barrett was quoted as saying that Moore's Law would have at least 10 more years to run, you know.
Well, Craig has never been bothered by being consistent.
Well, that's why he's always consistent. It's rolling 10 years.
Rolling 10 years. It's always 10 years in the future. I meant to say when we started that Morris and I are going to chat about these things for a while, and then we're going to look for questions from the audience. I'm sorry I didn't say that earlier. I'd like to turn to another subject that you and I chatted a bit about last night and again today. The technology that we're using in the semiconductor industry today now is pretty old. if you look, almost everything we do is decades old, and much of that came from large industrial laboratories. Bell Laboratories certainly was one of the sources of this, and they did not only the transistor but some of the processing technology. Won the Nobel Prize for that. TI did the integrated circuit, and Jack Kilby, of course, won the Nobel Prize for that. But those laboratories are gone now, whether it's IBM or Bell Labs or TI, or I mean, TI doesn't do much research anymore. And so, if we're going to fulfill Craig's prediction of 10 more years of this technology, do we have the technology necessary to do that? And if not, where do you think it's going to come from?
It's not certain, but I think that the probability of following the Moore's Law progression is still very high, the success probability. But there's another answer to your question, but let me just talk about Moore's Law, just getting on with Moore's Law. We're at 45 nanometer now, and the next generation is 32. And we are almost 100% confident that that one will happen. And then the next one is 22. Now there, we are not absolute certain at all that that will happen. Lithographically, I think there's still problems. 22. And then the next one down the stream is 12. And that is even less certain. So this 10 years thing could be that it might take 10 years to get to 12, rather than just 6 years. I think I frankly think that the nodes will be stretched out. I frankly think that we're not going to follow this 2-year cycle time anymore. So far we have pretty religiously.
Yeah.
But I think that as we get down to, I think 32, as I said, will still happen in 2 years. 2 years after the 45. But the 22, if I had to predict now, I would say that it would not happen 2 years after 32. But maybe Craig still thinks that even 22, even 12 will happen in this 2-year per node time frame. Well, if he thinks so, good luck to him. I don't think that we're going to be able to follow him, frankly, if he does that. But basically, the 10 years does just cover the Moore's Law progression. Now, I think that we got to have a post-Moore's Law world. Now, there is where this big research is missing. Mm-hmm. Now, we used to have Bell Labs, IBM. Now, we don't have those anymore. Now, I think each company, and really in the semiconductor industry today, I think there are 3 companies that have the resources and also the willpower to try to come up with new devices and new technologies, the post-Moore type of devices technology. Those 3 companies are Intel, we, TSMC, and Samsung. Now, those 3 corporate laboratories will have to come up with the new stuff. Now, it would be very different from the Bell Lab days. The Bell Lab inventions were available to everybody.
They were.
And I don't think that in the new world, I don't think Intel's results, our results, Samsung results will be available to anybody else. So it's.
Well, if you go back, it seems to me there were two events that drove this. One, in the 1956 decree against Bell Labs, all of the patents which they had on transistors that were made available to everyone. And then the litigation between TI and Fairchild over the integrated circuit in the early 1960s led to almost that technology being available in an open way as well. And patents after that became a trading mechanism as much as anything else. And you think that'll break down as well if it's Intel, Samsung, and TSMC, and are the technology inventors in the future? You think that?
Do I think that there will be licensing and so on?
Yeah.
Yeah, I think there'll be licensing, but I think the capital requirements are so high that I don't think there'll be many interested licensees. Now it takes about $5 billion to build a fab, a 45 nanometer fab.
12-inch wafer.
12-inch wafer. And the number is still going up. We expect that it will take more to build a 32 nanometer 12-inch fab. Not to mention the possibility that the wafer size may increase also. Basically, it doesn't mean that these companies will enjoy monopoly rights, because I think the major innovations are still going to be in the architecture, the design of the ICs, and the new applications. So the innovation, the gravity of innovation, I think it already has in the last 20 years gradually moved away from just the technology. Back 20-some years ago, when we started TSMC, the gravity of innovation was very definitely in the process technology end. But in the last 20 years, it's already gradually moved away from that towards the architecture design. And I think that in the future, that movement will continue. So there'll be plenty of opportunities for innovation and entrepreneurship in the architecture and design area.
So you think, last night we chatted a bit about one of these days there will only be one silicon fabrication facility making 450 millimeter wafers and supplying all the world's need, because nobody else can afford to build a fab and get the gains in sales on it. You don't think we're headed for that yet?
I don't think so. I don't think so. I think we are heading towards a few these companies. I mentioned 3, but that's mainly logic and memory. You have linear, that's still a world of small fabs, specialized fabs.
But you mentioned that SMIC has a 12-inch factory in China.
They have more than one 12-inch factory.
Oh, is that right? More than one? And there's more than one outside the Shanghai area. That seems to be kind of the nexus of semiconductor activities right now in China.
Well, I believe they have one in Beijing, but I'm not an expert on SMIC, so.
Yeah. Well, let's see. As I remember, you're having a slight disagreement with SMIC over who owns some.
I really don't want to talk about them.
Okay. Let's turn to China for a minute, because you know, China is a huge market, and they've tried to get into the semiconductor business for many years. And are they going to succeed this time around? Do you see China as a growing force in the semiconductor?
It has to be. It has to be. Intel is going to build a fab there, and we already have an 8-inch fab there. And as you said, you know, SMIC has got quite a few fabs there, and there's a number of small foundries that have fabs there. Now, in addition to all these fabs, they have over 400 fabless companies. China has over 400 fabless companies. Now, almost all of them are small. I think there are only a few that are more than $100 million sales. The total sales of the 400 or 500 companies, I believe, is in the $1 billion range.
Of the fabless companies.
Of the fabless companies, yeah. I believe it's well, maybe a little over $1 billion now. Maybe $1 or $2 billion now.
Are they selling outside of China as well? Is this mostly an internal market for them?
They sell mostly internally, but also some outside China. Yeah. Now, I believe that there's where I think China will grow in both. Well, first of all, China, just a few numbers that I keep in my mind just to give the proper perspective to the Chinese semiconductor industry. China uses 30% of the world's ICs. By using, I mean, they either assemble those ICs in equipment and then sell them outside, or they, of course, use them in China. But 30% in value of the world's ICs end up being assembled in China for either export or domestic consumption. China designs 1% of the world's ICs. That's the fabless company. Okay, it designs 1%. China manufactures in one form or another. They either fabricate, or they assemble, or they test. So you have to translate all these things to their equivalent number. You know, just as I have translated the foundry. I said that you have to multiply the foundry revenue by 3 or 4 in order to get at the final value of the stuff you're making. Now, so you have to do that kind of arithmetic with the testing in China, the assembly in China, and the foundry in China. So if you do that, you end up with the conclusion that China makes about 10% of the world's ICs. So those are the three numbers. It designs 1%, makes 10%, uses 30%. Now, it's the 30%, of course, is a huge number. It's a number that no semiconductor company anywhere in the world can ignore. That's but the 1% and the 10%, I think, will both grow.
As I remember, Morris, from visits to Taiwan, there's 1 or 2 million Taiwanese now working in mainland China out of a population of 22 or 23 million.
Yeah.
And there are other companies like Intel and others are building facilities. Do you see a risk at all in this growth in China You think it's a pretty risk-free to get into this huge market that you've just described?
Risk for the people who get in there, or
well, risk for the companies.
Risk.
Are they likely to lose their investment there, or is it?
Well, I'm sure that risk always exists. I remember back in the 70s, I guess, I was in the United States. I was working in the United States then, Texas Instruments. And we had a lot of Japanese visitors, and the favorite comment of the Japanese visitors was that in the semiconductor industry in Japan, what did they say? Many people are going to lose much money.
Right.
Yeah. So I think I would make the same comment about China. You know, many people are going to lose much money. Yeah.
Well, I remember from earlier days in trying to set up factories in China, there were very strict rules on taking profit out of the country. And they tried to tie it to sales outside the country. And is that still a risk of if you sell just to internal markets in China? Are there?
Well, I guess if the market keeps growing, then you don't want to take money out of the country. You want to keep injecting or reinvesting the money, the profit you have made, if you make any profit. If you make any profit, you keep reinvesting in China because the market is growing. Of course, if you lose money in China, then you have to send new money in all the time. Well, frankly, we are still losing money in China. We have a fab, as I said, an 8-inch fab in China, and we have had it since 2004, 4 years now. And we're still losing money. It's the only fab that we have that's losing money. We have a fab in the United States also. Very high labor cost area, as you know. High engineering salaries, high labor cost, and even there we make money. In fact, we make quite a handsome profit from the U.S. fab. But China, we lose money. Yeah.
I remember chatting with Gordon Moore once about the factory they were starting up in Albuquerque, and he said it eats like an elephant and defecates like a flea. And they weren't getting anything out of it.
Yeah.
I want to turn to one more issue, then I'm going to open this for questions from the audience. I know you're quite interested in education and improving the education in Taiwan, and you've hired a lot of people from the United States, or people who've come from Taiwan and gotten their degrees here and come back to Taiwan. What do you think of the education system worldwide today? The United States has traditionally, in one survey, at least in The Economist, I remember at 18 of the 20 top universities were in the United States. And is that a monopoly we can't hang on to, and are universities getting better, students getting better from all over the world?
I think that's a monopoly that the U.S. will hang on to for quite a while. If you, having gone to some top U.S. universities, Harvard, MIT, and Stanford, also having exposure to Taiwan universities and Chinese universities, I would say that it will take a while yet. It will take many decades yet for the Chinese and Taiwan university to reach the same level of excellence as Harvard, Stanford, MIT, Berkeley, as those universities have. If they try, if the I think the Chinese university, at least some of the Chinese universities, are trying very hard, and they have made a lot of progress in the last 10 or 20 years. Tsinghua and Beida and Jiaoda, I think, and Fudan. I think they have made a great deal of progress in the last 10, 20 years. The Taiwan universities, unfortunately, have made less progress. I really think that campus democracy practiced to a fault in Taiwan is to blame. You need reformers for a university to really make change. You need change agents. But when the president of the university, when the deans of the university are all elected basically by the faculty, then the change agent doesn't there's no source for change agent. Now, well, if you go back in history, Bill, I would think that the models of excellence in the 19th century were probably Cambridge and Oxford.
Absolutely.
Yeah.
And some of the German universities.
And some of the German universities, right. Yes. And the 20th century, I think, was an American century in universities too. All this, of course, has a lot to do with the national power, national wealth also. So the U.S., I think, still is a great power and still a very wealthy one. So I think it will hang on to this educational excellence. And it's really a very precious asset, I think.
It absolutely is. And, I think if you look back at the history in this country, certainly the World Wars I and II had a major impact on that in a time when the American universities grew. And the government played some role in that with the research on radar and other things in the late 30s and early 40s. And it's an interesting point of the transition from Europe to America, and now where might it go? Certainly Asia is a power. The entire area is a power rising. So.
Yeah.
Okay. Well, with that, let me see if there are questions from the audience, and if we have answered everything that anybody ever wanted to know. And
you wonder how semiconductor would fit into globalization, or?
Well, I wasn't sure how semiconductor was talking about
global security. Well, maybe I think maybe Ken is a better authority on this. I think it's important, particularly when in the so-called dual use aspect. Dual use means both civilian use and military use, and some semiconductors obviously fit this dual use definition. And the reason I mentioned Ken is he just told me that he was principal deputy assistant secretary in the Department of Defense on dual use something, well, maybe.
No, what you have to put this in context, and it's not only global security, but it's technology and innovation as well. And in my view, one of the reasons that the United States today is preeminent, whether it's in technology capability or generation of new companies or a strong economy, even with the crisis that we're currently in, and maybe we're just on the slippery slope heading into it, is that if you look at this country, we've been a technology leader now since the early part of the 20th century, certainly sometime in the 1930s or earlier. We have an extremely innovative area. People can start companies here. Failing is not a stigma. In fact, it sometimes looks good on your CV for the next company that you want. You may get more money because you now know what to do, not to fail. So I think you have to think about it in all of those contexts, and certainly a strong economy, a good technology base is an important aspect of global security. Right or wrong, the United States today is playing global policeman, and we couldn't do that. In fact, Semitech got started in many ways because the Defense Department, in a Defense Science Board study, said we cannot have our military capability, our defense capability, dependent on foreign sources of technology. So I think those things all tie together in something that's important to countries, and why Europe and Japan and Taiwan and Korea and Singapore and the United States push the semiconductor technologies. My view, it's kind of the base of everything we do. If you count the transistors you've got on yourself today, I expect you'll be surprised at how many are. And then if you've got a pacemaker or hearing aid or the things that us older people suffer from, you've got even more. And I just think the semiconductor industry will drive, and as Morris points out, as we go to 30 nanometers and 20 nanometers and 10 or 12 nanometers, it's going to open opportunities for things that we don't do today.
Do I see Asian nations becoming more nationalistic or less? Well, Asia has a lot of countries. I do think that some countries are perhaps as nationalistic as they ever were, and some other countries are becoming less nationalistic. Basically, I think you might say that the big countries in Asia perhaps are becoming more, or at least they are as nationalistic as they ever were. And the smaller countries in Asia have become less nationalistic, I think. That's inevitable, you know. I don't think the small countries can afford to be too nationalistic.
It's not if they want to eat, I think. Just one comment, and I'll go to Karen. There was a wonderful editorial by one of my favorite economists and one of my least favorite politicians in the New York Times not long ago. And he pointed out that if you look at the world, and the world at that time was mostly Western Europe, up to 1914, it was very globalized. All kind of things that you had in England or Germany or France or other countries or the United States came from all over the world. After 1919, every country became very nationalistic and closed their gates to globalization. And then it wasn't until well after the Second World War when those things began to open again. And now the question is, with the kind of conflicts we're running into, is that cycle going to come back and globalization will plateau or drop? I think it's a fascinating question, and a question about Asian countries. Karen, you?
Yeah, going back to the education question, there's been some trend over the last 5 to 10 years for some American universities, some of the best universities, and some other universities who are not well known, but who are setting up foreign universities abroad, primarily for graduate students, but and so that they see this as a source of graduate talent and where the market is going to be, and so they're setting up universities in Bangalore, India, Hyderabad, places in China, Singapore, other places. What do you think this impact will be with universities like Stanford, other universities, some small universities, who want to build their brand in the United States by having outstanding graduate schools in Singapore, for example? How do you see this playing out? Do you think this will have an effect on the U.S., on the
I think that the results are mixed. In some places, I think that the results have been good. In other instances, the results have been rather mediocre. And the faculties of these American universities actually are in disagreement. Well, at least there is disagreement. You know, so many of them don't like their universities to set up these branches to spend a lot of resources overseas. Basically, I think from the Asian countries' point of view, if they want to develop great universities, and I think they really, at least China and India, have made up their mind, or Japan also, have made up their mind that they will develop great universities. Basically, they still have to do it themselves. And this business of having branches or programs of American universities, I think is just a intermediate step. I think basically they have to do their own.
Well, let's see, there's a question way back in the back.
I can't hear.
Yeah. Can do we have a microphone? Is it we can't? Or come up this way and
yeah, come up this way and yeah. Hi. Come even closer, would you please?
We had a discussion last night about the advantages of hearing aids, and they're not as good as glasses. So.
I found fascinating your discussion or your mentioning of how you created a new business model in order to become innovators in the semiconductor business. And I was wondering more specifically, how did you change from a follower to a leader in such a competitive high-tech industry, focusing more on like the capital investment side and the human capital side of things?
How did we go from a follower to a leader in technology? I mean, we were a leader, I think, in business model innovation to begin with. In technology, how do we? Well, I think it was just a lot of hard work and recruiting. We did recruit a lot of PhDs and so on from the top American universities. That they also had a few years of working experience here as well. But we also recruited thousands of engineers from Taiwan universities, and we are one of the top preferred employers in Taiwan. In fact, we may be the most preferred employer. So we have a big drawing power as far as Taiwan graduates are concerned. and we recruited literally thousands of them. We actually, our people composition is quite different from a normal IDM semiconductor company. About half of our total population have college degrees, and in fact, of those that have college degrees or higher, 3/4 have masters and PhDs. So in a total population of approximately 20,000 people, we have about 6,000 or 7,000 people that have master's degrees or higher. So to answer your question more simply, you know, it really is the work ethic is very good in our company. People, you know, generally spend more than 50 hours a week in the fab, in the lab, or in office. 50 hours. The standard week, of course, is the same 40 hours, but most people spend 50 hours. And we did get top people. So we gradually caught up. It took us 10 years to catch up. We started as 2 generations behind, and then in 10 years, it wasn't until about, well, it took actually more than 10 years. We started in '87, 2 generations behind, and I think we caught up about '99 and 2000. So it was 12, 13 years when we caught up.
Let me second what Morris said. People work 40, 50 hours, 60 hours, except in France, right? And I think we get
no, I don't think they work quite that many hours in the United States now.
Well, yeah. Okay, we can discuss that over a glass of wine. But it was when I first visited Taiwan many years ago. It was almost like a reunion for me. I'd go back. I'd run into all these people I'd worked with at Bell Labs and at Xerox PARC and all these others. In fact, we had parties once in a while. We got together and talked about how good it was in Taiwan and what was wrong with Bell Labs and all the other things. So. Morris is exactly right. It's people, and they were able to attract the very best people. Many were Chinese, Taiwan nationals who had come to this country, had been educated here, and had worked here for many years, and then had gone back. So I think that's a really important point.
Well, actually, there was perhaps another thing. In fact, when I came here, before I came here, I asked 2 vice presidents for their ideas on the talk today, and one of them said something interesting. He said that we were able to catch up in 10 years because we were non-dissipative. So I said, what do you mean by non-dissipative? He said that in the companies he used to work in, U.S. companies, there was a lot of dissipation because of company politics. He said, you have to protect your position, and you have to protect your power or whatever, and you end up fighting each other. He said that he was really pleasantly surprised when he came to TSMC that there was none of that sort of things at all. So I agree with him, because I do know that we have no company politics at all. So,
we got a question back here, and then I'll come.
You talked about the prospects for the semiconductor industry
to address
global climate change.
Oh. Well, of course, the example that first comes to mind is solar power. I mean, that's semiconductors. And so solar power is a very definitely alternative energy that will reduce the the possibility of climate change. And I think that one is going to be solar power is going to be a reality. And that's the most obvious one I can think of.
Also semiconductor electronics are going more and more towards lower power. So everything that's got a high electronic content may be using more power, but it's using less from the semiconductor design. But it's a real problem. I think Morris is right. But and the amount of greenhouse gases to make semiconductors is fairly large, and I know that's something that the companies are working on.
Yeah.
So if we're able to design ultimately silicon devices that don't require any power, we got it made.
Solar power. You're mentioning this, or you're reminding me of solar power. Just reminds me of another anecdote about Jack Kilby. Jack Kilby was the inventor of integrated circuit that got a Nobel Prize in 2000, and he died shortly afterwards. Jack Kilby was a very innovative person, and one of his innovations that did not materialize was a way of making solar cells. But we invested at Texas Instruments. We invested more than 100 engineers, at least 3 years of time in developing Jack Kilby's solar cell idea. Well, I mean, it was very good. We were successful in making solar cells the way he felt, a very economical way. But unfortunately, the oil price started to go down. And so the solar cell was never economically competitive. And I asked Jack at that time, I said, what price does oil have to go to before our solar cell can become competitive? And his number at that time, this was in the middle 70s. Yeah, 75, 76. He said $100. $100 oil price, then our solar cell will become competitive. Well, you know, Jack Kilby never saw $100 solar price before he died. Now the oil price has now gone up to you know what it is now. So I asked the solar cell businessman. I said, "What oil price is it now? Does it have to go up now before the solar cell can become competitive?" And the answer is $200 now.
Was that Craig Barrett who asked that question?
Yeah. But still, the solar cell people are getting better, you know. So I think the $200 I think is a rather pessimistic. I really think that with the oil price the way it is at a little over $100, I really think that solar cell is going to expand.
I do too.
Yeah.
We'll take two more questions. I'll take one here in the front, and then we'll take one towards the back there. So, and then Morris will be here. Hold on, you're going to be second right after this. Morris is going to be here for a while afterwards. So if you didn't get to ask, we'll share. What do we have? Beer and wine, diet sodas next door, and he'll be here for a while more. So.
My question is with the amount of growth that you have so far, I was kind of interested to know what challenges you see in 10 years time from now to achieve
Well, I think that Bill cited our half-year growth number, so 30%. Indeed, the first half, I think we did grow 30% over last year. But what he didn't say, and I'm saying it now, that last year was a very bad first half, and this year first half was quite good. So that's why we came up 30%. But secularly, I mean, long term, if you look at it, we are not growing nearly at that kind of rate now. So growth is a challenge, and it's not something that we can overcome, because basically we are still a part of the semiconductor industry, and semiconductor industry growth has slowed down considerably since the year 2000. In the decade between 2001 and 2010, I think the semiconductor growth will only average middle single digit, like 5%, maybe 6% per year during this 10-year period. Average growth per year, 5-6%. So and the foundry, I think, since foundry is enjoying more outsourcing from the IDMs, the foundry growth will be faster than the semiconductor industry growth. But it's not going to exceed 10% either. So semiconductor industry will grow 5 or 6% a year average. Foundry, like us, TSMC growth, I do not believe will exceed average 10%. I think in some years we'll do better than 10%, but in other years we will do worse than 10%. But the average will be about 10%. Now, 10% growth, of course, is good for a lot of industries, but for technology industry and for TSMC, it's somewhat disappointing. So you asked about challenges. Well, we have to try to figure out a way to grow faster than that, and still keep our profitability, and that's important too.
Okay, come on up this way.
May I ask you to come a little closer also? Yeah. Mm-hmm.
Nowadays, as technologies keep scaling down, we've been hearing about this design of wire manufacturing or wire design. As we go to 45 nanometer, designers have an extra set of recommended design rules, because it has come to the point that design and manufacturing has been having a lot more interaction with each other. So you may argue that.
Well, that assumption, if that happens, then foundry is in trouble, or design is in trouble too. I think that the reason we are able to operate so well is because the physical interface doesn't really have to be very close. I mean, all this started with all these algorithms that were invented, or that were accomplished almost 30 years ago. Carver, Mead, and so on, design rules and so on. So they have been well in place, and designers don't have to interact with the manufacturing people so closely.
But nowadays, like, there's a tendency that at first it was the foundry take care of everything, and then it was an interactive procedure, kind of you can say this like now, or not needed practically, and the designer can rewrite it. It was an interactive procedure. So as this tendency grows, how have you been
I know in TSMC there has not been an increase in interaction. In fact, we're investing a lot of our R&D money into what we call design services, and the function of this design services group is precisely to reduce the necessary interplay, as you call it, between, yeah.
But engineers have always been playing tricks to reach further than what we are already blessed with. So my question is, since it has been 21 years, so your original vision of the pure foundry for TSMC, do you have any plans or have you been repositioning this, or the world is a lot different than it was decades?
We position ourselves as an IDM. Is that your question? Reposition ourselves as an IDM?
As an integrated device manufacturer, not as IBM, but an IDM. That is where the design and production is all done in-house rather than an interface.
Is that your question?
Yes.
Oh, no, because there will be that will be quite bad, because if we get into the design business, get into the product business ourselves, we'll be competing with some of our customers. And then if our foundry competitors stay as pure play foundry competitors, those customers that we will now be competing with will end up going to our competitors, foundry competitors. I don't think that we want to do that.
I think you. Yeah, I think you're putting your finger on a really important question, and that is the technology that TSMC has that allows them to satisfy a customer who's 10,000 miles away and doesn't have the interaction that you're proposing, which is traditional in this, that you tweak your design, send it through again, and then tweak it again, but that's now done on a long distance basis. I don't know how many cycles you might get from a customer to change their design. First time they're so good now.
I have never. No. So my way of thinking is to what is the right thing to do to bring that result? That is kind of a little confusing right now with design and manufacturing.
Right.
But this is your business model. The world is driven by profit.
That's true.
Yeah.
Okay. We need to quit. Okay. Well,
Yeah,
my boss says we can have a couple more questions.
Well, in our investment in design services, we try to reduce the design cost also. In fact, I think the answer lies in reusability of a lot of these modules. If the modules, the IPs, if the IPs are reusable, then the cost of a new design, which uses many of the same IPs that have been used before, will be lower. And that's the direction we're going. If it weren't for that, I think that the design cost for each new generation will even increase more rapidly. It's not that the design cost. We don't call it the capital thing. It's not a fixed asset like. It's not something that you you have to buy before you even start doing anything. It's design cost is a labor intensive, and it's mainly design labor, designers. Well, I think it's for the 45 nanometer generation. It's in the order of $50 million per design, and that already uses quite a few IP reusable IP blocks.
You have to sell a lot of widgets to get your money back.
You have to, yeah, you have to sell.
How much of that is mask cost for PDA tools of the 50
I don't think any of it is masks. I think it's just the labor of the designers. I think. And the mass set cost has increased with the technology. I don't know what it is now. I don't remember what it is now.
Expensive.
It's quite expensive. I know it's quite expensive.
But I think what Morris is saying is it's $50 million on the design side before you turn it over to the foundry to fab what's there, and the fab eats the mask.
No, the fab does not. We don't pay for the mask.
Oh, you don't?
No, sir, no, sir.
They are. I didn't know that. You charge the customer for the mask.
Oh yes. Wow. We like to charge customer for other things too.
Okay, I'm going to have one more question, and then we're going to have to. I go to the front row here. Sorry about that, and you'll have to come up and get Morris after we.
Last week in class, we learned that TSMC was buying back some of their stock from their shareholders, and we were just wondering what is the thinking behind that?
Oh, usually, you have two ways of rewarding your shareholders. The most obvious way, of course, is a dividend. But share buyback is also considered a way of rewarding your shareholders, because if the company buys back shares, the share price is always determined by supply and demand. If the company buys back shares, it increases the demand on the shares, and therefore the share price goes up a little bit, and every shareholder benefits from that. So now we prefer the dividend way. Of the two ways we have, of the two ways that exist of rewarding shareholders, we prefer the dividend. But we do our incentive program is such that we do give some shares to employees as a bonus every year. So we at least want to buy back the shares, the number of shares that we have given to employees, so that we don't have any dilution. So that's why the buyback you refer to is not a very big number of shares. Also, I guess in the last 2 or 3 years, since our original major investor, Philips, wanted to sell their shares, so as of about 3 or 4 years ago, we reached an agreement with them to sell their shares in an orderly manner, and as a part of the program, the company also bought back some shares from the market. But all that has now ended. Philips has finished selling their shares, and there's no more overhang of their shares. And We did buy back some shares as part of that program also. But the recent one, the one you referred to, was to just buy back the shares that we gave to employees.
Well, let's thank Morris for.
Thank you.
I think we could have gone on all night.